Hey everybody, welcome to Bill Sky, the Assembly Guy, and we're going to start our discussion today with functions. How do we actually create a function in assembler language, and how do we use it? We're also going to go over how to set these functions up externally so we can link those functions into any assembler language program that we write. So we're going to be just generating an object file. And now, let me just say, this is going to be your introduction to functions. It's not going to be the quote-unquote right way to write functions, but it's a way to get started. And then when we start talking about stack frames in a few videos from now, we're going to go ahead and show you the right way to do it. So we're going to do this on Windows, we're going to do this on Linux, and we're also going to do this on ARM RISC processors. And those will all three be separate videos, so the videos aren't just huge, okay? So anyway, so let's get started with simple functions in assembler language. All right, simple functions in assembler language. We're going to start off with Windows. Now Windows, compared to Linux, compared to ARM, is more GUI-like. In other words, you're doing things with a GUI user interface. You don't have to, but it's much easier. But it's not necessarily as fast as Linux or in ARM. So I'm going to show you the way to do it using Visual Studio, which is the tool that most people use for assembler language. And then we're going to do it in other videos on Linux and ARM using basically command line stuff. And it actually, for me, it actually is faster. But anyway, so let's get started with Windows. Now I'm just going to go ahead and start up my Visual Studio. And once Visual Studio is up and running, we need to create a new project, but we're not going to create a new assembler language project like we normally would from templates, but we're going to create a library project. So the way that you do that is you click on New Project, and I'm going to come down and I'm going to select C++. Under Project Types, I'm going to select Library. And there's a number of different ones you can select. You can select a dynamic link library and a static library. Now a dynamic link library means that the library, when you compile your main program and you use these objects, a dynamic link library means that you just share a DLL file. You share the object file with everybody else. It's not actually attached to your executable assembler language program. However, static means that it's actually physically attached, and that will make your assembler language program larger, but you won't have to supply the DLL, the dynamic link library. So if you don't have that installed, the user might have problems getting it installed. So you kind of have to weigh this. Is it going to make my program so much larger, and so many other programs are going to use my functions? Should I attach it to my executable, or should I make it as a shared dynamic link library object file? We're going to do static library. So go ahead and click on static library and say next. And we're going to call it, I don't know, let's call it some functions. Actually, let's call it some ASM functions. And we're going to make this 64-bit. And I'm going to click create. So there are some there are some things that we have to do, which is why I believe the Linux and the ARM ones are easier. But we do have to do some things to the project. Now, first of all, it's going to create some source files for you. It's going to create this pch.cpp and the some asm functions.cpp. What we want to do is we want to select both of those, and we want to delete them. So I'm going to click on remove, and I'm going to click on delete. And the other thing that we need to do is we need to go in and do some build customizations. We have to set it up. Now we're going to do this as 64-bit. 32-bit is very much the same. You're just going to be picking x86 instead of x64. So what I'm going to do is I'm going to right click on the project, not the solution. I'm going to right click on the project, and I'm going to go to build dependencies, build customizations. And from there, I'm going to click on MASM, and then I'm going to click OK. So once you get that done, you're pretty much ready to go. You've now enabled your project for MASM. So what I'm going to do now is I'm going to right-click on source file, and I'm going to say Add New Item. And you can pick all templates if you want to make sure it's going to be a CPP file. But you don't want to make it a CPP file. You want to say some functions.asm. You want to make an assembler language program. Or it shouldn't be a program. It's going to be a file of assembly. It's going to be a source file, an assembly language source file that's going to include your functions. Okay. Now you can do this from a normal assembly language program, and we're going to do that as well. I'm going to show you how to do that to make the functions actually part of your main assembly language program. But what we're going to do here is we're going to make it as a separate file. Okay, so I'm going to add some data. Now I'm just going to copy this data or this source file from some notes I have. And let's talk about it a little bit. So this looks like an assembly language program. It's got a data section, and anything in that data section will be available only to your functions. So if you have like 5 or 10 or 20 functions in this functions library, and they're all going to use maybe some constants or maybe some variables, you can put those in the .data section. So those will be global to all of your functions. Then we have a code section, and the code section shows our first function, which is add2. Now, how do I know that's a function? Is because it has the word PROC at the end, procedure. So function is equivalent to procedure. And that's the way we used to call them. We used to call functions procedures, subroutines, but I guess when C came out in the late 70s, early 80s, they started calling them functions. But they're really still procedures. So that defines the beginning, and the name of the procedure is add2. And what is this going to do? Well, it's going to take RBX, put it in RAX, and it's going to take RCX and add it to RAX. So this function add2 is basically just going to take RBX and RCX as arguments, and it's going to add them together and put them into RAX. And then the function is going to return. Now notice that there's nothing after the word RET, return, and that's because assembly language functions do not return values like a C or C++ or Java or Python function does. You don't actually say return this data. What you do is you put the data to be returned always into RAX. Whether it's a pointer, whether it's a value, whether it can even be a floating point number or an integer. Anytime you return something from a function in assembly language, it should always be returned in RAX. Now, if this was 32-bit, you would return it into EAX. But the accumulator register in Intel assembly language is always the return register. That's how the data gets back out into the real world, or into the function that called this function, is RAX. And then you have this little thing here. You have the function name endp, which stands for end procedure, end proc. And that's really it. You now have your very first function. You could create another one, add2, or not, instead of add2, you could say subtract2, procedure. I could move into RAX, RBX, subtract from RAX, RCX, and then return. So you can make as many of these as you like. Okay, so let's go ahead and save and build that. All right, now let's take a look at what it says there. We've got some errors here. Let's see what we have. It says error, syntax error, add2, procedure, symbol redefined sub2. That's kind of interesting. End directive required for the end of the file, which is absolutely true. You actually have to put the end right there at the very end as well. Oh, and I made some errors here, so we have to say, oh yeah, we did some, I can't believe I did that. So let's say add2 should have endp at the end. Sub2 should have np. I don't remember typing that. So it's not in my notes, so I'm not really sure why that happened. Okay, so we had some very simple little mistypes there. So we've got add2, the procedure, add2 is defined there, then add2 is the end procedure right there. Sub2, the procedure begins here, sub2, the procedure ends there. And end means that's the end of my source file. I've always found that kind of weird that Windows requires that, but there you go. Now, where's my object file? This did not create an executable file. I cannot run this file. If I go up here and debug and start without debugging, it's going to say unable because it doesn't know where the it doesn't know where the entry point is. It's got some kind of weird, yeah, it says it's not a valid Win32 application, which means it doesn't have a main. So there's not a start function, there's not an entry point basically. So you can't actually run this because it's just a set of functions that you're going to be using in a main program. So what you can do is, if you want to find that object file, I'm going to right click on some ASM functions and I'm going to say open folder in File Explorer. And what we're doing, we're on the hunt for our object file. So I'm going to go to x64, debug, and there it is right there. Actually, which one is it? Let's see. Yeah, I don't see the object file. I see a recipe file. Let's go into there. Visual Studio makes this a little bit difficult. So I'm going to go into x64 instead, debug, and there's my object library file. And it's called some ASM function 64.lib. Also, there's something else that's bothering me a little bit about this. Yeah, so that's a lib file, but then we also need an object file. And there it is right there. And this is one of the things I really dislike about Windows is it doesn't show you the final extension of this. So I'm going to right click on this and I'm going to say wonder if there's a way on Windows 11 I can open a terminal right there. Or maybe I could say view, show. See, it's not easy to do this on Windows. I wanna look at the file extensions. So let's go to Objects. View. I like that feature. It says hide extensions for known file types. I'm gonna check that. Press apply and OK. And now you see it right there. Confusing as hell. Oh, excuse my language. Oops. Confusing as HE double hockey sticks. That object file, it's kind of weird. Windows is weird, as it doesn't show you the file name extensions, so you kind of have to change Explorer to be able to show it. So that's the file that we're looking at that we just built. Now what I like to do is I like to create a folder on my C drive, and I'm going to right click on there and I'm going to say new folder, and I'm going to say ASM libs. So I'm going to create a folder on my C drive called ASM libs. I'm going to open it up, and I'm just going to hold down my right mouse button, drag that object file into my ASM libs folder, and say copy. And so it copies that object file. So now I can use that object file on any program I want. Okay, so let's go ahead and close that. And now I'm going to say File, Close Solution. I'm going to create a new project. Now this time I'm going to use the Komanetsky templates. So I'm going to turn off C++, I'm going to turn off library, and I'm going to scroll all the way down, and I'm just going to use one of these templates right here. And now you have to match, your main program has to match the cardinality of the function library. So the function library was 64-bit, so we have to use a 64-bit library, or a 64-bit main. So I'm going to go ahead and double click on my template. I'm going to say ASM use functions 64-bit, and this is going to create an assembler language program. Now this program is not using any of my functions, not at all. It isn't linking with them, nothing. The first thing I need to do is I need to create a prototype for my functions. So I'm going to say add2 is a prototype, subtract2 is also a prototype. So what that does is it allows your assembler to say, okay, add2 and sub2 are defined somewhere else. I'm not going to worry about it in my main code here. It's going to be handled during the linking process. So it's a prototype. It's just like a prototype in C and C++. We simply say, hey, assembler, don't worry about it. I'm going to provide that to you in the link. All right. So now there's a number of different things that we have to do. We have to go in and we have to make that object file available to the linker. So the way that you do that is that you right click on your project. Oh, before we do that, let's go ahead and save and build this. And it looks like, oh, yep, this is an old template, so I have to go up, right click on the solution. I have to say retarget. So this error simply says that I created this template using the Visual Studio 2019. We may have seen that before in some of my videos, so I have to retarget it for the most recent. So I'm going to build my solution. Now notice it built okay, even though add to and subtract to they're not linked. Okay, but because my program is not using them, the linker doesn't worry about it. The moment that I put those in there, and let's do that. So if I remember correctly, RBX was our first argument, RCX was our second argument, and then I'm going to say call add to. And then RAX will contain the sum of those two. So I'm going to save. Now that I'm using add to, let's see what happens. Now I get an error, unresolved external. It doesn't know where add to is. And I guess if you look at this a little bit closer, yeah, right there, unresolved external symbol add to. So the linker had a problem with that. You can also see that it's an LNK. LNK 2019 is the return code or is the error code that I couldn't find add to. So what we have to do is we have to let it know where that function is, and it's in our object file. So what I'm going to do is I'm going to right click on my project. I'm going to go to properties. Oh, I think I clicked on the wrong one. Yep, you got to do the properties of the project, not the solution, the project. So properties, there, much better. And what we need to do is we need to expand linker. We need to click on input. And let me see, actually we have to go to general first. And we have to say additional library directories. It's always kind of difficult. You drop down that and you say edit. And I'm going to click on the new line. I'm going to click on the ellipse. And I'm going to go to my C drive. There's my ASM libs. So we have to tell it where it can find the library files. So that's the first thing you have to do. And then I go to input and I specify under additional dependencies, edit, and I have to give it the library name. Now I completely forgot. I think it was somefunctions.obj. So let's go to ASM mylibs. There it is, somefunctions.obj. So I'm going to type somefunctions.obj and say OK, apply, OK. All right. So now I went ahead and told the linker, I need you to load some other object files. So I'm going to save and build it. And we still have a problem here. So I'm going to go back into the, oh, I know why, because it modified the 32-bit, I believe. So I'm going to go into properties. No, it modified the 64-bit. So let's take a look again. So I paused the video and I was looking, and this hits me all the time on Windows. If you notice, we're running debug, or we're building debug x64. Cool, right? However, I didn't set up the properties for debug. I set them up for release. So if I right click on my project and I go to properties, before it, for some reason it showed release. It did not show debug. It did not default to debug. I'm on debug on Visual Studio, as you can see here, but this was release, and you can see my sum functions there in the linker input. If I go down to general, you can see my C ASM libs. However, if I drop down release and go to debug, which is what I'm doing, they're gone. So you have to make absolutely sure that you pick the correct configuration based on what you're doing. And Visual Studio has all kinds of little caveats in there. So what I have to do is I have to go back in here and I have to go to additional library directories. So basically I have to do what I did first, but this time I have to do it in debug. And there's the directory. Then I go into input, additional dependencies. Notice we're still on debug, which is a good thing. Edit, and I have to add some functions.obj. I'm going to hit apply. I'm going to hit OK. Now let's see if it builds. I'm going to say rebuild. So it rebuilt. So it's okay. Weird, right? Visual Studio has all kinds of problems like that, and it's like they don't want to fix them. I don't know what's going on. Okay, so let's go ahead and debug this and see if our function works. So I'm going to put a breakpoint right there on line 17, and I'm going to debug, start debugging. And we're on line 17. I'm going to go up here. I don't see registers here, so I'm going to say debug Windows registers, and we can see that RAX has a value of 30. So we sent it 10 and 20, 10 in RBX, 10 in RCX, and it went ahead and ran because we put the breakpoint on line 17, and you can see that it did add them together. Now I'm going to go ahead and click continue. This time I'm going to put a no-op. I'm going to put a breakpoint on the no-op. And my mouse isn't quite, okay, there we go. So let's put the breakpoint on the no-op, and I'm going to debug it. And now we're going to step into the function. So I'm going to step over, step over, step over, and I'm going to click step into. And we can see our function source code. And the reason we can see the function source code is because we built the functions as debug, not release. If we built them based on release, we wouldn't see the source code. So we can watch what our code's doing. It puts the 10 in there, it adds the 20, and then it returns. So that's how you can debug it. And that's using an external library. Whew. I'll be really honest with you guys. I paused the video to find out what was wrong. It took me 20 minutes to figure out my mistake, that I hadn't clicked on debug when I was setting up the configuration. So we all make mistakes like that, and because I'm not a normal, I don't do everything in Windows, I do most of the stuff in Linux and Mac and ARM, I missed that. So you're going to find that you're going to do that as well. Okay, so one last thing I do want to do is I'm going to go into File, and I'm going to close the solution. And I'm going to do what I had promised you I was going to do. I'm going to create a new project, and I'm going to put the functions inside of my main. So I'm going to go down to, and let's do Komanetsky 64 functions template. And I'm going to call this ASM functions 2 x64. Now, when you put the functions in line with your main code, you don't have to worry about all this object files and stuff. But it also means that those functions are only available to my main program. So let's go ahead and do that. So this is the main program for my demonstration of using the Komanetsky functions. So what I'm going to do is I'm going to delete everything that I don't need, and I'm going to save and build this, and I'm going to run it just to make sure it printed hello world in program ending. So it's good. Okay. So let's go ahead and create our own function. Now, one nice thing about Windows assembler language is that I can create my functions anywhere I want. So I'm going to say add to proc, and I'm going to say add to np. So I can actually put my functions below my main. The assembler will handle that. In C and C++, you have to put your functions above your main. But I'm going to go ahead and put them below my main. And I always have to make sure I do a return. Okay, so I'm going to do the same code that I did in my functions. I'm going to move into RAX 10, or no, I'm going to move RBX. I'm going to add to RAX, RCX, and I'm just going to return. So that's a simple little function. Now, one thing you might want to do is you might want to put some comments here, inputs, rbx and rcx will contain values to add, return. And you should do this for the external object file too. RAX will contain the sum of the two arguments. You might want to even put a little thing about how to use it. How would you actually use it? So let's go ahead and save and build this. All right, now we're going to go ahead and use it. So I'm going to say move into rbx10, move into rcx20, call add2. And then I'm going to put a no op here so we can actually see if it did it correctly. Notice we didn't have to worry about object files. And you might think, ooh, that's the way I want to do it, right? Well, you don't want to have to keep rewriting your functions every time or copying and pasting them into every one of your programs. So it's really best to create an object file, an object file of your main functions, and then just use them and make sure that you document your code very, very well. Okay, there you go. So let's go ahead and debug this. Now I'm going to put a breakpoint right there on my very last no op, and I'm going to debug it. Oh, started without debugging, sorry. So I'm going to debug, start debugging. And RAX should contain a 30, which it does. So we did 10, we did 20, and this called the inline function, which is part of our main program. Now, one last thing I did want to go over is how do you create an include file for your projects, for your external functions. And let's go ahead and close this solution. And now I'm going to bring up my use functions, SLN. That's the project that I had so much trouble with because I didn't set up debug. So what is an include file? Well, an include file simply has constants and maybe the prototypes, your function prototypes. And normally what you'll do is you'll create this inside of your main object file. So I'm actually do that. I'm going to go into my C drive, and I'm going to go into my ASM libs, and there's my sum functions. I'm actually going to create a file in there. I'm going to create a include file. So I'm going to use my Notepad++, and I'm just going to create a new file. And I'm going to put in those prototypes. So I'm going to say add to proto, subtract to proto. If I wanted to, I could create some constants in there. So normally an include file has that. An include file contains all of the constants and all of the prototypes that your program is going to use. So I'm going to save that. And I'm going to actually do that in my C drive. And I'm going to name this exactly the way I named it on the object file. So I'm going to call it sumfunctions.inc for include. I'm going to close my editor. So now you can see that we have an include file which contains the prototypes, and we also have the object file. So now I don't need them in here. Now I can go ahead and get rid of those. However, if I save and build this, I didn't specify where add2 is located. I didn't actually do the prototype in my main program, so we have to make another change to our project. And what I'm going to do is I'm going to go into the VC++ directories, include directories. I'm going to add a new folder that we should search for, and that's going to be on my C drive ASM lib. So the include folder is where I put my include file. Click apply and OK. Now if I build it now, it's still not going to build because I didn't specify the include file inside of my main program. I actually have to have an include file in there. So we need an include and like an import statement. So that is a %include. and you want to put in the name of your include file. So we called that sum functions. So what's going to happen is when we build this, the assembler is going to look in that directory, ASM libs, that we specified in the properties for the project, and then when I say include, it's going to go into that directory and it's going to find the include file. So let's go ahead and build that. And now it builds just fine. No problem, 0 failed. So that's how you would create an include file. You would specify the include directory. You need to make sure you're doing that. Now, I don't know if you noticed, but I did not pay attention. So when I went into properties and I added that include directory right here, I didn't check to make sure I was on debug. Watch what happens when I switch over to release. Boom. Now there's another thing you can do is you can pick on the active configuration that you've got up in Visual Studio. So if I change it to release, next time I go to properties, it'll bring up the active one. But you still have to pick it. That's not the default. The default always seems to be release, and you've got to do it that way. So the very last thing I want to talk about on this whole idea of calling functions is that you have to somehow maintain or protect the previous values in registers. And this is where the stack comes in. We talked about this in an earlier video. And what you do to make the stack, to protect the stack, is that you push the values into the stack before you actually call the function. Or you can actually have the function itself protect those variables. So let me show you what I mean. So in this program where we're calling the object file, we're calling the add to function in this case, what I want to do here is I want to protect RBX and RCX because they may have some value that I was using earlier before I put values in them. So what I might want to do is I might want to push RBX, I might want to push RCX. So, and what that's going to do is that's going to save our argument registers in this case. So let's save them to the stack. And then when we're done with the function, we're going to pop RCX and we're going to pop RBX. So that's going to give us the values that were previously in those registers. And that's just going to be restore our argument. So that way we can modify a register before we actually do anything to it. Now, that's in the main program. What if I wanted to change this in the actual function itself, which is actually a very good practice because what you're going to do is you're going to be protecting the user's data. So let me actually build this and make sure it's okay. So let's go back into the function library. So I'm going to go into File, Close Solution. And now I'm going to go into my functions. And I believe, yep, it was called some ASM function. So I'm going to go back into there. And inside my function itself, I'm going to say push RBX, push RCX. And then when I'm done, I'm going to say pop RCX and pop RBX. And notice I do them in the opposite order in which I push them, because that's how a stack behaves. Now, you might look at this and say, well, why bother with this? Why? Because I'm really not doing anything with RBX and RCX within my function. I'm just using the data that's in them. Absolutely correct. You're absolutely correct. So I really don't need to do those for those variables or for those registers because I'm not modifying them inside the function. You want to look at your function and say, am I modifying something that the user that called me might be using? And so I save them using push, and then I restore them with pop when I'm done using them. Very good. But you as the programmer have to decide when to do that. Should I do that in my main program? In this case, the answer is yes. You want to do it in the main program because the main program is what's modifying, in this case, RBX and RCX. But you don't really need to do it in the function because you're not modifying them in the function. All right, great. So that is creating a function, an inline function in your Windows assembly language program, and it also shows you how to create an object file that you can then use in all of your other programs, much like my Komanetsky functions for assembler, and also Kip Irvine in his assembly language book He also has the Irvine libraries. It's the same thing. You have to have an include file. You have to actually link to that object file. And hope to see you at the Linux video.